if you don't like expanding the logs, maybe you think that makes them look more messy, we can use the properties to just undo all of that and take an expanded expression and condense it all into one log. So using the same properties, we can do what we just did, but backwards. So in our first example, we have the expanded expression log base 3 of x plus 2 log base 3 of y. So we basically just want to do exactly what we did, but the opposite order. So the first thing that we should look at is numbers in front that should end up in the exponent. So here we have 2 times log base 3 of y. So the 2 we can throw up into that exponent. And then we just have to pay attention to the sign in front of each of our logs. Since both of these are positive, that means they would have expanded from a product. Right? So they're going to condense into a product. So we're going to have log base 3 of x times y squared. You can double check yourself just by re-expanding it. Right? That would expand into log 3 of x plus 2 log 3 of y. Should look the same as when we started. It does. So we've condensed that equation. One other example, here again we have all of the pieces we've got. So we have products in front, so that means we're going to end up with powers. We have some logs that are positive, so we're going to have a product. We've got a negative log, so we're going to end up with a quotient. And then I threw in this 1/2 to maybe try to throw you off just a little bit, but I don't think it will. So we have our natural log, so this is all going to condense into one natural log of something. And then we see that there's a negative in here. So let's just go ahead and put in our fraction. And any log that's positive goes on top. Any log that's negative will go on bottom. Okay. Let's look in the front and put our constants there back into the exponents. So 3 is going to go up and become x cubed. I'm going to skip over that 1/2 for a second. And then here we have this 4 would go back up into y to the 4th. So let's think about this 1/2. We would have z to the 1/2, but think about what a 1/2 power is back from chapter 6. I would hope that you remember that something to the 1/2 power is the same as a square root. So it might be nicer to write this as natural log of a square root of z. Okay? So again, any log that's positive will go on the top. Any logs that are negative go on the bottom. So natural log of x cubed is positive. So on the top of this, we're going to have x cubed. That natural log of square root of z is positive. So we'll have a square root of z up here. And then minus natural log of y to the 4th. So that y to the 4th will go excuse me, into the bottom. I want us to think about one other thing really quick. Having to do with the negative logs. So let's pull out negative 4 natural log of y real quick. If we take the negative 4 and put that into our exponent, then we would have natural log of y to the negative 4th. And something to a negative exponent is the same as 1 over that, right? So maybe that helps you see a little bit why, if our log is negative, we can just put that in the bottom. That's just really skipping the step of putting a negative exponent up there and then using that negative exponent to instead divide by that term.